superposition of n collinear harmonic oscillations with equal phase difference. Before going to discuss this topic, I would like to tell about representation of simple harmonic motion. So earlier we represented a simple harmonic motion in terms of displacement given by y equal to a sine omega t. This is a sine function. So a SHM may also be represented in terms of cosine function also. Now today I will tell you that a SHM can also be represented in terms of exponential function given by y is equal to a e to the I omega t. Now let us see whether y is equal to a e I omega t is representation of simple harmonic motion or not. Now take the first derivative dy dt. So dy dt is equal to d dt of a e to the I omega t. So a will come out of the differentiation symbol, then d dt of e to the I omega t. Already you know these things, I taught you in your class. So I omega will come out, I omega a e to the I omega t. Then take the second derivative, d2y dt2 is equal to d dt of I omega a e to the I omega t. Now I omega will come out after differentiation. Here another I omega will come out, so this will be I square omega square. So a e to the I omega t will remain there. So a e to the I omega t is equal to what? Y. So this is omega square y, because I square is equal to minus 1, already we know. So this implies d2y dt2 plus omega square y is equal to 0, which represents the differential equation of a simple harmonic motion. So we can say that y is equal to a e to the I omega t represents the displacement equation for a SHM. Now let us come to our topic. Let us consider n number of harmonic oscillations represented by, suppose y1 is equal to a e to the I omega t, y2 is equal to a e to the power I omega t plus delta, and y3 is equal to a e to the power I omega t plus twice delta, and yn is equal to a e to the power I omega t plus n minus 1 delta. Here we have seen that a is the amplitude which is same for each of the wave, and delta is the phase difference which is constant between any two wave. So phase difference between y and y2 is equal to delta. Similarly, you will see that phase difference between y2 and y3 is equal to will also be equal to delta and delta delta. So delta is the constant phase difference. Now according to the principle of superposition of waves, we can write the resultant displacement as y is equal to y1 plus y2 plus y3 plus yn. So I have written the values of y1, y2, y3 like this. Okay. Then consider common a e to the I omega t. Then this will be 1, and this will be e to the power I delta, and next it will be e to the power twice I delta, next e to the power thrice I delta, and lastly e to the power n minus 1 I delta. Now you will see that this is a GP series having common ratio e to the power I delta. Then that will be equal to a e to the power I omega t. So you can write like this, 1 minus e to the power I delta. Here 1 minus e to the power n I delta. Next we can write a e to the power I omega t, 1 minus e to the power n I delta by 2 plus n I delta by 2, that is equal to n I delta. Similarly, e to the power I delta by 2 plus e to the plus I delta by 2, that is equal to e to the power I delta. So next step, a e to the power I omega t, and you take common here e to the power I delta by 2. Then this will be e to minus I delta by 2, and this is e to the power I delta by 2. Okay, similarly you can consider common here e to the power n I delta by 2, and this will give you e to minus n I delta by 2, and this e to the power n I delta by 2. Next we can write a e to the power I omega t e to the power n I delta by 2 e to the power I delta by 2, and this will be sine n delta by 2 divided by sine delta by 2. So how it comes? So you know e to the power I omega t is equal to cos omega t plus I sine omega t, or e to minus I omega t is equal to cos omega t minus I sine omega t. So from here, if you write e to the power minus I omega t minus e to the power I omega t is equal to how much? And this will immediately give you minus twice I sine omega t. So using these expressions, that can be written like this. So here e to the power n I delta by 2 omega t is equal to how much? This is n I delta by 2. So this we can write here actually what, minus twice I it will come, minus twice I it will come. So they will cancel out each other. Okay, next we can write this term as e to the power n I delta by 2 minus I delta by 2, that is equal to I n minus 1 delta by 2 a e to the power I omega t, and second term will remain as it is. And this you can write like this, e to the power I omega t plus n minus 1 delta by 2 sine n delta by 2 sine delta by 2. Okay, then you can write a sine n delta by 2 divided by sine delta by 2 e to the power I omega t plus n minus 1 delta by 2. So we have got y is equal to this much. Suppose this is our equation number number 1. Okay, let y is equal to r sine omega t plus phi be the resultant displacement. So equation number 2. So comparing 1 and 2, we have what is r? R is equal to a sine n delta by 2 divided by sine delta by 2. So this is the resultant amplitude, and phi is the phase difference between the wave y1 and resultant, and phi is given by what is phi? N minus 1 delta by 2. So equation 1, 2 will give the resultant displacement having a resultant amplitude r and the phase angle phi, which is done with the first wave. Okay, next class.